All right, let's break down a core concept in Linux that you really need to know, the inode. So, to kick things off, let's ask a simple question. What is a file, really? Most of us probably think something like this. It feels intuitive, right? But it's not the whole story. Because, well, that's just not how systems like Linux actually think about files. The real object here is the inode. So, the inode is the file's true identity. It's completely separate from its human-readable name. And this separation of the name and the identity, it's one of the most important design ideas in Unix. Okay, so how does this all work in practice? Let's say you want to open a file called notes.txt. First, the system looks inside a directory. It's basically just a lookup table mapping names to inode numbers. Then, the system reads that inode number. It holds all the metadata and, most importantly, pointers to the data blocks. Okay, with this model in mind, a lot of confusing file system behaviors suddenly make perfect sense. Let's look at a few. For instance, have you ever wondered why renaming a huge file is instantaneous? The system isn't touching the data at all. It just changes the text in that directory table. The file's real identity, the inode, is completely untouched. This model also makes the difference between hard and symbolic links crystal clear. They're fundamentally different things. Same goes for deleting a file. It's not instantly erased. The system just removes the name and updates a counter. And this explains a classic mystery. If a process still has that file open, the inode and its data just hang around. But what about this error, especially when you think you have plenty of free space? This is where inodes really matter.
You see, you can have plenty of disk space, but be totally out of inodes. They're completely separate resources.
This typically happens when you have millions of tiny files. And once you're out of inodes, you can't create new files. So what's the big idea here? It all comes down to a really elegant design principle: separation of concerns. You've got the human-facing name we use and the system-facing identity the computer uses. This separation is powerful. This whole pattern, a name that's just a reference to the real thing, is huge in computer science. What else works this way?